Hello, good morning. Factors affecting the magnitude of delta crystal field stabilization energy. Generally, the crystal field splitting is depends on the extent of repulsion between the lesion electrons and metal d electrons. However, the several factors affecting the magnitude of crystal field stabilization energy are as follows. Oxidation state of the central metal atom or ion. Is the oxidation state of the transition metal affecting change on metal age increases? The surrounding lesions, electron donors are attracted more closely to the central metal center. Oxidation state of transition metals is increased. That is, the number of positive charge increases. The lesion surrounding, that is the electron donor, that is the nuclear charge. So they are attracted more closely to the metal center. The orbitals on the lesions interact more strongly with the d orbitals, and hence the crystal field stabilization energy increases. The orbitals on the lesions interact more strongly with the d orbitals, and hence the crystal field stabilization energy increases. For example, hexaocopherate have +2 delta naught 9100 per cm. Hexaamino cobaltate Thor 23,000 per cm. Number of lesions and geometry of complex. Generally, the number of lesions is significantly varies with the geometry of complexes, such that the splitting in square planar complexes is comparatively higher than octahedral and tetrahedral. Similarly, octahedral splitting is remarkably larger than the tetrahedral splitting. Number of lesions significantly vary the geometry of the complex, so is splitting square planar complex comparatively higher than octahedral. Square planar have 4 lesions higher than octahedral. In case of tetrahedral, also have the 4 lesions, and octahedral have 6 lesions. But the crystal stabilization energy is lower than octahedral in case of tetrahedral, but higher in the square planar than octahedral complex. Nature of metal ion play an important role on the value of crystal field stabilization energy. It is observed that crystal field stabilization energy in the train 3D, 4D, 5D. The crystal field stabilization of the similar complex with the similar charge on the metal increases by about 20 to 25 from 3D series to 4D series. Same trends is in the 5D series. The increasing in the series is due to the more interaction of larger metal d orbitals with lesions on descending the group. nature of metal ion play important role in the value of crystal field stabilizing energy. It is observed that the crystal field stabilizing energy in the train 3D have the least and 4D have greater than 3D and 5D have greater than 4D. So nature of metal ion play also important role in the value of crystal field stabilizing energy. The crystal field stabilizing energy of the similar complex with the similar charge on the metal increases by 20 to 25% from 3D to 4D series and same train into 5D series. The increasing in series is due to the more interaction of larger metal d orbitals with lesions and descending the group. 4D principal quantum number 4, azimuthal quantum number 0 to n minus 1. So n equal to 4, L equal to 0 to 4 minus 1, 0 to 3, that is the 0, 1 to 3, SPD of magnetic quantum number minus L to plus L. So if L equal to 3, minus 3 to plus 3, minus 3 to minus 1, 0, plus 1 plus 2 plus 3, spin quantum number of anti-clockwise and plus half is the clockwise. In case of hexaamino cobaltate third, 23,000 per cm. Hexaamino rhodium or 34,000 per cm. Iridium, hexaamino iridium 41,000 per cm. Nature of regions. The splitting of behaviors are greatly influenced by the nature of regions. The lesions are arranged in order of their increasing splitting ability called spectrochemical series, which categorize the lesions as strong and weak field lesions. Usually, the strong field lesions cause the greater degree of crystal field stabilization energy, and the weak field lesions cause the small degree of crystal field stabilization energy. Hexaoka farad second of 9100, 9100 per cm, and hexaamino cobaltate third 20,000 per cm. Lesions, nature of lesions, nature of metal ions, D, 3D, 4D, 5D, nature of number of lesions, that is tetrahedral, octahedral, and square planar apples, and oxidation state of central metal atom and affect the magnitude of crystal field stabilization energy. So there are 4 factors: oxidation state, nature of lesions, nature of metal ions, and nature of lesions, nature of metal ions, number of lesions in geometry, oxidation states affect the crystal field stabilization energy. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That is now. Bye-bye.